Today actually I am going to start your exercise 6.4 of chapter 6, and here exercise 6.4 is all about the areas of two similar triangles. So here I am talking about theorem number 6.6. The statement is the ratio of the areas of two similar triangles is equal to the square of the ratios of their corresponding sides. You need to understand the meaning of this statement and you need to write the mathematical explanation of this statement. Here what is told that you are having two triangles. Suppose triangle ABC and one more triangle you are having, that triangle DEF, and both the triangles are similar. It is already told that both these triangles are similar. If it is told in this statement, if triangle ABC is congruent to triangle DEF, then area of their square, area triangle ABC upon area triangle DEF is always equal to AB upon DE, AB upon DE, and here AB square and DE square, then AC upon DF, AC upon DF, and it is also in the square, then it is equal to BC upon EF, BC upon EF, it is also in square. This is the mathematical explanation of this statement. That means if two triangles ABC and DEF, both these triangles are similar to each other, that means area triangle ABC upon area triangle DEF is always equal to the AB square upon DA square, and it is equal to AC square upon DF square, it is equal to BC square upon EF square. That is the meaning of this statement. The ratio of the areas of two similar triangles is equal to the square of the ratios of their corresponding sides. So here you can see that AB side is corresponding to side DE, and that means AB square upon DE square is always equal to AC square upon DF square, and it is equal to BC square upon EF square. Like that, you have to understand the statement and write their mathematical explanation that I was talking in my live class, that we have not to prove the theorem, but we have to understand the concept behind this theorem, and these concepts will be applied to do the questions of exercise 6.4. Okay, so now I am going to start exercise 6.4. First of all, you note down this statement and its mathematical explanation. Okay. After writing it, you will be able to do the sums of exercise 6.4. So now let us see how to apply this concept in doing these sums. Now you can see in your book exercise 6.4, question number 1 is there. Let triangle ABC is similar to triangle DEF and their areas be respectively 64 cm square and 121 cm square. If EF is equal to 15.4 centimeter, find BC. So what to do? Here question number 1, you are having two triangles. It is given here that two triangles you can draw in the solution part. What are the things you need to write? First of all, what is given? In this statement it is given that triangle ABC is similar to triangle DEF. It is similar to triangle DEF. This is the first given thing, and their areas are also given, and area triangle ABC is given as 64 cm square. And area triangle DEF is also given as 121 cm square. These two areas are given there. Also, the third thing we are having EF equal to 15.4, EF equal to 15.4 centimeter. We need to find BC. We need to find BC. BC equal to what? It is better to draw two triangles there. So just draw the rough sketch of these two triangles ABC and DEF. Now after drawing it, you can easily able to see that EF, side EF and side BC, both the sides are corresponding sides of these two triangles. Side EF is corresponding side of BC. Now we will apply that concept of that theorem. Since the ratio of the areas of two similar triangles is equal to the ratio of the squares of corresponding sides. So that application will write here. Since area triangle ABC upon area triangle DEF is equal to, that is BC square upon EF square. EF square, that we know from the theorem number 6.6, which we have just discussed. Now here triangle ABC, area triangle ABC is given, that you have to put there, that is 64 upon DEF 121, that you need to write. Now the side BC is not given, just you need to write here BC square. Then down here EF is given 15.4, so you can write here 15.4 square. Now you need to calculate it to find its value. Okay, so you need to calculate. If you will remove the square on both sides, taking a square root on both sides, you need to write one statement that taking a square root on both sides, a square root on both the side, on both the side. If you will take the square root, then actually what will happen here, a square root of 64 is coming as 8 and a square root of 121 is coming as 11, and here you will have BC upon 15.4, BC upon 15.4. If you will do the square root of this 64 upon 121, and BC square and 15.4 square is at the right side. So if you will take the square root, then a square will be removed, and left side you will take the square root of this number. Ultimately you will multiply BC into 11, it will be giving you 8 into 15.4. Then further you can easily find BC, 8 into 15.4 upon 11. So by 11 you can cancel this number. So here 11 1 ja 11, and then point 11 4 ja 54, 11 4 ja 44. Okay, so it is 8 into 1.4. Therefore BC will be coming, you have to multiply 8 into 1.4, that will give you 11.2 centimeter. That will give you 11.2 centimeter. So like that easily you can find the measure of the side BC. So, this is the application of theorem number 6.6, that if two triangles are similar, then the square of their corresponding sides are always equal. So, if the ratio, you will take the ratio of the areas of these two triangles, then it will be equal to the square of their corresponding sides. So, like that you can apply the concept of this theorem in doing the questions of exercise 6.4, that is area of two similar triangles and their relations. So, this is question number 1. I hope that you have understood the application of the theorem 6.6. You just copy down it, and then I am showing you few more questions. This time I am going to take question number 2. Okay. In 2 number question, what is there? Diagonals of a trapezium ABCD with AB parallel to DC. AB, just you look at your book now, that AB is parallel to DC, intersect each other at the point O if AB equal to, length of AB is equal to twice of the length of CD. Find the ratio of the areas of triangle AOB and triangle COD. So, let us see this question number 2 also. Now, I am talking about question number 2, that how you will be doing this question number 2. Here it is given that diagonal of a trapezium ABCD, that means you need to draw a trapezium. Here in the solution part you need to draw a trapezium. Suppose this is the trapezium, okay, and here its name is A, B, C and D. Now you need to join the diagonals. Join the diagonals AC and BD. Join these two diagonals. Okay. These diagonals AC and BD are joined there. Then it is also given that AB is parallel to side DC. AB and DC, both the sides are parallel. Then length of AB is equal to twice the length of CD. It is also given in your question. So, what are the given parts here that you need to write here? What is given? First of all, you need to write let. The statement, if you want to write properly, you need to write let ABCD be the given quadrilateral. Be the given quadrilateral. Given quadrilateral, in which what the things given, that you can write the statement as per your own word, own understanding, in which it is given that AB is parallel to CD, and it is also given that the length of AB is equal to twice the length of CD. It is also given. Okay. Now we need to find what to find. You can write to find. What to find? Actually, what to find there? That we need to find the ratio of the areas of triangle AOB. That means area triangle AOB. You need to find area triangle AOB upon area triangle COD. Area triangle COD. This thing you need to find. Area triangle AOB upon area triangle COD. This you need to find, because they are asking find the ratio of the areas of triangle AOB and COD. Now, so first of all, you need to see these two triangles. You need to see these two triangles. That in this triangle, suppose the point of intersection of diagonal is O. Point of intersection of the diagonal is O. That means, first of all, you think about these two triangles. As you are aware that if AB line is parallel to this line CD, That means here this angle, I am talking about the angle CDO, it is always equal to the angle OBA. You can see both are alternate interior angles, so these two angles are equal. Other thing is that this angle DCO is equal to angle BAO. These two angles are also alternate interior angles that we know from the properties of the parallel lines. When two parallel lines intersected by a transversal, then alternate interior angles are always same. In that context, we can say that this DCO angle is equal to angle BAO. One more thing you can see that these two angles are equal because they are vertically opposite angle. That means angle DOC is equal to angle DOB. These are vertically opposite angles, so it is equal. That means clearly here in this figure you can see that both these triangles are similar. Okay. So here what to do? First of all, in the solution part you need to write what type of a statement that I am going to show you. So when you will go to write the solution, that solution to have started, but real answer, these are the figure and this is what is given in that figure and what is to find that I have written. Now in solution part, if I will start the question, first of all I will write, since triangle ABO, triangle in triangle AOB, in triangle AOB and triangle COD, in triangle COD, what you are looking there? In both this triangle, angle DCO is equal to angle BAO, that you can write the reason, alternate interior angles. Then again you can write about this angle CDO, angle CDO is equal to angle CDO is equal to angle ABO, this is also alternate interior angle. Okay. And third thing, you are having angle AOB, angle AOB is equal to angle AOB is equal to angle DOC, this is vertically opposite angle. That means I am writing VOA. Therefore, you can write triangle AOB is similar to triangle COD by AAA. By AAA congruency criteria. By AAA congruency criteria, you can see that both the triangles are similar to each other. That you need to write first. After writing it, that means if both the triangle are congruent, that means when you will apply the concept of theorem number 6.6, that means area triangle AOB upon area triangle COD will be equal to their corresponding sides. Now AOB, in triangle AOB, the side is AB. That means it will be equal to AB square upon CD square. That you can write there, that area of these two triangles, the ratio of the triangle, area of the ratio of this triangle AOB and COD will be equal to AB square upon CD square. Now what we need to write? Here I can write AB square, AB is equal to twice of CD, So I can write 2 CD there and here square upon CD square. So that ultimately it will be equal to 2 to the 4 CD square, 4 CD square upon CD square. So ultimately this 2 CD square will be get cancelled and here you will have number 4 upon 1. You will get 4 upon 1 there. What you are getting there? Area triangle AOB upon area triangle COD equal to 4 upon 1. That means you can write your final answer. This part I am cleaning so that I can write the remaining answer over there. So the remaining steps I am going to write there. Here what you need to write? Therefore I can write area triangle AOB upon area triangle COD is equal to 4 upon 1. Therefore that is equal to 4:1. So ultimately you can write your answer. That means area triangle AOB is to area triangle COD is equal to 4:1 and that is your answer. So you have got the answer of this question like that by applying theorem number 6.6, that the ratio of the areas of two similar triangles is always equal to the ratio of the squares of their corresponding sides. So this concept is used in doing various type of questions. What I have told you, that in geometry you need to understand the statement of the theorems, understand the definitions, then you can apply those concepts in doing question. You can treat those concepts as a formula, and these formulas are very important formulas. It will help you in doing so many questions. Okay. Now one more question I am going to show you. That question number, this time of question number 3, you can see question number 3 only just I am taking so that your confidence may come up. In this question number 3, I hope that you have written this, then I will discuss question number 3. Okay. So I am going to clean the board now. Okay, so you have seen question number 1 and 2. Now third number question also I am going to show you. In the given figure, triangle ABC, just you look at question number 3 of your NCERT book. This question number 3, what is given there? In the given figure, ABC and DBC are two triangles on the same base BC. Okay. If AD intersect BC at point O, so that area ABC upon area DBC equal to AO upon DO. So let me draw the figure first. What is given in this question? First of all, you are having a diagram which I need to draw first. Here the diagram is like that. You can draw this diagram and name of the sides is written here A, then here it is written B, then C and D, then C and D. Now BC is joined. So let us join this BC. BC is joined. Then AD is also joined. Join this AD. BC and AD is joined and they are intersecting at a point. That point is O. At point O it is intersecting. So now ABC and DBC are two triangles on the same base BC. you can see the same base BC. Okay, BC on the same base, ABC and DBC, ABC and DBC, these two triangles on the same base BC, they have given the same base BC. So, BC, you can see the base BC here, BC as a diagonal, it is BC is written over there, but it is on that base itself. ABC and DBC, ABC and DBC are on the same base. Okay, so you can see the base BC, and here ABC triangle and DBC triangle, you can see both are the alternate sides of this base BC. Okay, all right. Then you need to prove area ABC, triangle ABC and DBC is equal to AO upon DO. So, for this, what to do? For this, actually we have to do some construction work, then only we can prove. So, what construction we need to do over there? That draw a perpendicular. Okay, draw a perpendicular there on BC. From A, draw a perpendicular, its name take as AN, and another perpendicular from D you can draw on the same base, that like this you can draw the another perpendicular there, and here the name I can write as N. So, these two perpendicular is drawn on the base BC. From A you have to draw a perpendicular, that's name is AM on the base BC, and from D you need to draw another perpendicular which is named as DN and which is on the base BC. Okay. So, what is given there? Here in solution part, what I need to write? I have not written the given part, that you can write triangle ABC and triangle here DBC are on the same base BC, they are on the same base BC. To prove, it is given only to prove here, to prove what to prove, just I am writing what to prove. Area ABC, that when ABC is written like that, you can understand it is about triangle. Area ABC upon area DBC, area is equal to AO upon DO, equal to AO upon DO. This thing you have to copy down, then I will write the solution part of this statement. So, till here first of all you copy down. Okay. Now, one more thing I have written about construction. What construction is done there? That also you need to write. Draw in construction, draw AM perpendicular to BC and DN perpendicular to DN perpendicular to BC. That this is drawn, then we can prove it. So, till here first of all you write down, then I will write the proof. First you copy down the initial statement which I have written till now. Okay. Then I will clean here. Okay. Once you have written what is given and what is to prove, and construction also I think you have written. Now, in triangle AOM and in triangle DON, we will see in both this triangle. Now, when I will go for the proof there, then I have to check these two triangle. In triangle AOM, in triangle AOM and triangle DON, triangle DON. What you can see in both this triangle, what are there? AOM. You can see these two angles, AOM and this. AOM and DON, both the angles are equal. And you can see the second angle, that means angle AMO is equal to angle DNO, because both are 90 degree. So if two triangles, two angles are equal, that means the third angle will be automatically equal to each other. What we can say right here? Angle AOM is equal to angle DON, and reason is vertically opposite angle. They are vertically opposite angle, so both these angles are equal. And another thing, AMO is equal to angle DNO, and that is equal to 90 degree. It is coming by construction, So whatever construction we have done, according to that construction, these two angles will be equal. Therefore, automatically you can say that angle OAM is equal to angle DON. By angle sum property, automatically this angle will be equal. If two corresponding angles are equal, that means the third angle will be equal to the third angle. Therefore, triangle AOM is congruent similar to triangle DON. So in this case, both these triangles are similar to each other by AAA criteria. So you can write by AAA criterion, these two triangles are similar to each other. If these two triangles are similar, that means clearly you can write there that AM upon DN will be equal to AO upon DO. Because in congruent triangles, corresponding sides are proportional. That means the corresponding sides are proportional. That means if two triangles are similar, that means their corresponding sides are proportional. That means AM upon DN is equal to AO upon DO. This can be the corresponding sides of a similar triangle. Why it is? You can write there, that is corresponding sides of the similar triangle, So here you can see that corresponding sides of a similar triangles are always equal. Now area of triangle, now we will see the area of this triangle ABC and DBC. Okay, so now we will work for the areas. Okay, here this side I will write the remaining part of the question, or till here you need to copy it down, or I am going for the okay, you can copy here. I can write also area ABC upon area DBC is equal to area ABC. As you know, area ABC means, area triangle ABC means half into base into height. Base is BC and height is AM. And here area DBC means half base is BC and your height is DM. Your height is DM. So you can cancel this half and you can cancel this BC. That means it is coming as AM upon DN. It is coming as AM upon DN. And here AM upon DN is coming to AO upon DO. Here you can write this is your relation number first. You can write here this is your relation number first. And here whatever I have got, that is the relation number 2. So from first and second, you can write here from first and second, it is clear that, what is clear? That AO upon DO is equal to area triangle ABC upon area triangle DBC. Okay, I can write area triangle ABC upon area triangle DBC is equal to, what to prove? What I am going to prove? AO upon DO, that is AO upon DO, AO upon DO, and that is proved there. Okay, so it is proved. So you can see that how easy and simple proofs are there. You need to apply little bit your understanding, and logical thinking is very important in mathematics. Logical and reasonings are always welcomed by mathematics. So always stretch your brain, think about the questions, apply the proper formulas, proper theorems, and their gist or conclusion of the theorem are applied in doing sums of geometry. So today I am going to send you the solution of remaining sums also, so that you can do it and practice it to understand nicely. Thank you for today.